This looks like something straight out of a movie, pure CGI wizardry. But what if I told you it's 100% real? Everything you're about to see today is governed by the laws of physics. There are no visual effects, no camera tricks, just mind-bending experiments that look utterly impossible, but are completely real, prepared to have your reality questioned. First up, we have this video of water flowing upwards, completely defying gravity. Your brain is screaming that this can't be right, that the water should be splashing down onto the counter. But as you can see, it stays glued to the glass, climbing up and over the curve. So, what's happening here? It's not magic. It's a beautiful demonstration of two principles: surface tension and adhesion. Water molecules are incredibly sticky. They love to cling to each other. That's surface tension. They also love to cling to other surfaces, especially smooth ones like glass. That's adhesion. In this setup, the force of adhesion between the water and the glass is so strong, and the surface tension holding the water stream together is so effective, that they collectively overcome the pull of gravity for a moment. The water takes the path of least resistance, which is to follow the curve of the glass. It creates this stunning illusion that gravity has somehow been switched off. But don't worry, gravity is still very much in charge. It's just being temporarily outsmarted by some very sticky molecules. Next, get ready for water that literally dances on fire. It looks like a computer animation, with droplets skittering and gliding across a red-hot surface as if they have a mind of their own. This is the Leidenfrost effect, and it's one of the coolest, or should I say, hottest phenomena in physics. When a liquid droplet, like water, lands on a surface that is significantly hotter than its boiling point, something amazing happens. It doesn't just boil away instantly. Instead, the bottom layer of the droplet vaporizes so quickly that it creates a protective cushion of steam. This vapor layer acts like a hovercraft, lifting the rest of the droplet off the scorching hot surface. With almost no friction, the droplet is free to float and slide around, pushed by the slightest air current or its own internal agitations. It looks alive, like it's trying to escape the heat, but it's simply a perfect, real-world example of thermodynamics in action. It's pure physics, no CGI needed. Now, look at this. It's as if this surface has a personal vendetta against water. Any liquid that touches it is instantly rejected, bouncing and rolling off like a tiny silver ball on a pinball machine. This isn't a filter or a visual effect. This is a super hydrophobic surface. The word itself sounds complex, but the idea is simple. Hydro means water, and phobic means fearing. These surfaces are engineered at a microscopic level, with incredibly intricate patterns. Think tiny pillars or ridges that are so small they trap a layer of air. When a water droplet lands, it's not actually touching the solid surface, it's resting on that cushion of air. Because water molecules are so attracted to each other, they pull themselves into a near-perfect sphere to minimize contact. The result, the droplet can't spread out or wet the surface at all. It just rolls away at the slightest tilt, taking any dirt or dust with it. It looks completely fake, but it's a very real and incredibly useful piece of material science. Prepare to be mesmerized by this airy, black liquid that seems to come alive. It morphs and spikes into incredible shapes, looking like an alien symbiote from a comic book. This is ferrofluid, and it's one of the most visually stunning things you can see outside of a special effects studio. Ferrofluid is a liquid that's filled with infinitesimally small magnetic particles. On its own, it just looks like a dark, oily puddle. But the moment you introduce a magnetic field, everything changes. The tiny particles inside the fluid immediately align themselves with the invisible magnetic field lines. This forces the entire liquid to contort and rearrange itself into these sharp, spiky patterns. The stronger the magnet and the closer it gets, the more dramatic the spikes become. You're literally seeing the shape of an invisible force. It looks like something conjured up by a VFX artist, but it's a direct, real-time response to the fundamental laws of magnetism. Finally, we have a substance that can't decide if it wants to be a liquid or a solid. Watch this. You can gently dip your hand into it, and it flows around your fingers like thick cream. But if you try to punch it or hit it with a hammer, it instantly becomes hard as a rock. This is a non-Newtonian fluid. Most liquids we're familiar with, like water or oil, have a constant viscosity. They flow the same way no matter how much force you apply. But a non-Newtonian fluid breaks that rule. Its viscosity changes dramatically under stress. The most common example is a mixture of cornstarch and water. When you apply sudden, high pressure like a punch, the cornstarch particles lock together, resisting the force and acting like a solid. But when you move slowly and gently, the particles have time to slide past one another, allowing it to behave like a liquid. It's a physical property that seems to defy logic, an impossible material that you can actually make in your own kitchen. It just goes to show you that reality doesn't always behave the way we expect it to. The universe is filled with wonders that are far stranger and more beautiful than anything we could animate. So, which one of these experiments fooled you the most? Let me know down in the comments. Thanks for watching, and don't forget to subscribe for more reality glitches.